So, what is ECG? History of ECG. This we have done. I have explained which indications for ECG. Leads we have explained. Right leg always is for earthing, ground electrode. This I think should be no problem. Thomas triangle, Goldberger's leads, augmented, frontal plane leads, and transverse plane. This is covered the system already. At home you should practice how to bring to common ground. Precordial leads, transverse plane leads. These are frontal plane leads. Anatomical groups we have discussed. You may take this one at first AVL, V5, V6 is lateral, V1, V2 are septal, and so on. V3, V4 anterior. Additional leads, how to place heart electrical axis, how to determine heart electrical axis. That nowadays normal is from here minus 30 up to plus 9. And this is what from here to here? From 0 to minus 30. This is which deviation? First of all, it's written left. Second, it is physiological left axis deviation. Third, we have summary table. Why I'm telling you this? During the exam, not to be surprised. This will be asked. Just a minute. Deviations I told that we have 3 axes, normal ECG. We'll start from this to understand how this formation. About calculations, I told one small box is. Okay. Maybe next movie attentive. But before starting, one issue about your exam order, how it should be. This year, according to new requirements that everything is going to international standards, we'll have practical skills with another format. Up to this year, we were doing like this. At first, we were writing test. Then you are coming to exam oral, where you had 4 questions, 3 theoretical initiated, and 4 is practical skill. Practical skill is from this list. Blood pressure measurement, I don't know, heart auscultation, phonocardiogram analysis, okay? Lung auscultation, lung percussion, and so on. Interpretation of the image and ECG interpretation. For you, just now, determination of heart axis, heart rate, pathological changes is not for you. This just by mistake is remained. No pathological changes, just determination of heart rate, axis, and pacemaker. Rhythm is coming from sinus node and so on and so on. Now, this year it has been changed to OSPE. Not OSCE yet, but OSPE standards. Which means that each group, before starting oral exam, will be 3 questions. 4th questions is removed from there, has been brought as OSPE format. In OSPE, you will have 1, 2, 3 questions, each of you. It will be in written format. Now by computer or paper-based, we'll decide and tell you. You are answering to these questions. For example, what is this? For example, I don't know. Lesion cyanosis. Recognize cause mechanism. Or in which conditions, like this. Okay, and your practical skill is from this year. I think will not give. It is just pilot program. Will not give marks like 30% of final mark, but those students who will answer very well during oral exam will take this into account, and maybe 1 point we may increase. Okay, so in this format, it is still in process because just the day before yesterday we came to this conclusion. I mean, because programs are being changed. For example, these first year students are studying it, students which should come from September. From the start they will have this program. And there are hours are changed, the names of the subjects may be changed, the same propedeutics may be in internal diseases part, like this, doesn't matter. Anyway, ECG we need. Okay, so now look. Listen and make notes, though we have spoken about it. This is anatomy of conduction system. Heart consists of 2 types of cells. Cardiomyocytes, which is functional myocardium, contractile cells, and pacemaker cells, or myocytes.
Yes.
The function of myocytes is formation, producing, and propagation or propagation of impulse. From sinus node up to Purkinje fibers, all are myocytes of various levels of differentiation. Heart conduction system, anatomy, consists of nodes and pathways. We have two nodes, SA node and AV node. SA node is localized in upper part of right atrium, subepicardiale. AV node is localized between atrial ventricles on the right side of interatrial septum. From AV node starts his bundle, which then is going and is being split into the branches. Accordingly, the right is going to the right ventricle, left is going to the left ventricle. Left also has anterior and posterior vesicles. This is SA node schematically. Here is AV node. Here is his bundle. This is right branch. This is left branch. This is anterior vesicle. This is posterior. And each of them ends in Purkinje fibers. On the level of Purkinje fibers, electrical impulse is being transferred from myocytes to cardiomyocytes for them to depolarize and to contract. Normally, impulses are formed in, this is first class pacemaker, SA node, which gives impulses from 60 to 100 impulses per minute. Second, this is first class pacemaker. First class pacemaker. When we say pacemaker, artificial pacemaker, in your program we don't mean artificial pacemakers. We natural pacemakers. First class, second class, AV node, which gives impulses 40 to 60. His bundle less than 40. Purkinje fibers less than 20. Together, his bundle and Purkinje fibers are called his Purkinje system. So his Purkinje system is third class pacemaker. Third class, and this is also third class. As you understand, up to down, automaticity decreases. Automaticity is this is still physiology, is the unique ability of heart to produce impulses and to contract in response to them. That's why isolated heart for a while continues beating. You will understand why we need this. For example, in left atrial enlargement, right atrial, this all is being changed. Impulses, normally the only pacemaker is SA node. We have spoken about this. It is the king, Raja, Khalif, I don't know. As you wish. Yes. King, queen, first. The one and only. All others are servants, are just transferring impulses taken from SA node. So this activity is not seen. AV node and so on, secondly. But heart is designed in a very wise way. Why it is working like this? There is a principle, physiological, it's called overdrive suppression, which means that above standing structures are suppressing below standing structures. And the highest automaticity is SA node, so it suppresses all other parts. If in physiology you are passing like this, if for some reasons first class pacemaker is not working, starts to work, second class pacemaker, this is not working, third, but in reality it is like this. AV cannot work because it is suppressed from impulses by SA. But one beautiful day, when AV node, like literally of course, imaginary, opens eyes and reveals that there is no suppression, starts to give its own impulses. Normally, the only rhythm should arise from SA node. It is called sinus rhythm. SA node, sinoatrial node, or sinus node. So the rhythm which is coming there is SR, sinus rhythm, or NSR, normal sinus rhythm. If your pacemaker is localized here even, very close but out of SA node zone, it is called ectopic. Ectopic, remember. For example, if it will be AV nodal rhythm, it's ectopic. Will be atrial rhythm, it's ectopic. Will come from ventricle, it's ectopic. Of course, we mean conduction system. Ectopic means out of its normal site. We have ectopic pregnancy, when instead of uterus, for example, it is coming from tubes.
Yes.
It's a life-threatening condition from gynecology UPA. So it's ectopic, out of its usual site. So any focus which is out of SA node zone is considered to be ectopic. Ectopic doesn't mean that we don't have, for example, AV. We have, but they should not work normally. Normally should work only SA node. They should only transfer. I mean, they should not produce impulses. But look, how below is the structure, less is the heart rate. Because these impulses per minute are becoming beats per minute. But for the heart, it's better to contract by 40 beats than not to contract at all. By 20 than not to contract at all. Of course, as you understand, for example, less than 20 cannot last very long, few minutes. Either we should restore sinus rhythm or patient will die. Because hemodynamically it is not beneficial. Too much not beneficial. It's catastrophic. But, for example, with AV nodal rhythm, patient may live whole life. So, in other words, all these ectopic rhythms, these are called, write down, passive ectopic rhythms. This here we are not speaking about arrhythmias, but these are called passive ectopic or escape rhythms. Passive ectopic or escape rhythms. This is atrial rhythm. This is AV junctional rhythm. This is also AV junctional rhythm. This is called idioventricular or ventricular rhythm. These are called passive ectopic or escape rhythms. Look what as a result what we have. When I told that it's better for 40 beats per minute or 20 than 0, these rhythms are keeping heart safe from long periods of asystole. Otherwise, if only SA will work, SA is not working, patient is dying. This hierarchic structure, very hierarchic, it is working very hierarchically. That above standing is higher than below standing. But if for some reasons this is not working, start for this one. If this is not working, this one and so on. This part was clear. Now let's come back to conduction system anatomy. So, impulses which normally are produced, it is called Gaskell's law of automaticity, if you remember from physiology. That automaticity gradient up to down decreases from up to down. Normal impulses are formed in SA node, are transferred to AV node according to physiological data by 3 pathways. Torrens, Wenckebach's, Bachmann's. It's a bit disputable, yes. These are called internodal pathways, from node to node. It is disputable, why? Because even now in 21st century, some authors are telling that only Wenckebach is working, others two are reserved. Anyway, 3 pathways which are connecting SA with AV. Left atrium, this is called again Bachmann's branch, Bachmann's like this, but it's it's general term. By Bachmann's branch is receiving impulse 002. This is, remember, this is right atrium. You remember, yes, this is right ventricle. Here is left atrium, will be and left ventricle. So from right atrium to left atrium, impulse is arriving 002 seconds later. So accordingly, P waves has 2 peaks, and between them the distance is 002. Normally should be. It is again called Bachmann's branch. this is from right atrium to left atrium to depolarize. First of all, we will have depolarization of right atrium because sinus node is localized there. From right atrium to left atrium. And here we have three pathways. Torrens. Should be like this. Venke box. And Bachman's. When reaching to AV node, here we have physiological delay 0.08 seconds. Impulse is coming to AV, is stopped here for a while, then goes further. Why? It is allowing atrium to depolarize and contract first, then ventricles. Otherwise, we will have all together. It happens only in case of complete AV blocks, when atrial and ventricular rhythms are completely dissociated. And it's very much, again, not beneficial for hemodynamics. It means that atrial and ventricles contract against each other, which should not be. Atrium should contract, send the blood, yes, to the ventricles contract, to send the blood to the great arteries. This part is clear. Then impulse is going is bundled by left and right branches and ends in Purkinje fibers. Left parts receive impulse a bit earlier, you remember? That's why M1 then T1, A2 then P2. Because this left branch of this bundle is considered to be a bit shorter, you may imagine like this, or anyway, a bit earlier, left parts, 0.01 second, or 50 to 100 milliseconds later, right part receives after left. Now look, heart is designed in a way that these are called intercalated discs with gap junctions. That without significant loss of energy, without any resistance, impulse is spread. It is due to unique intercellular connections. Electrical currents are spread from SI node to Purkinje fibers. On the level of Purkinje fibers, impulse from myocytes is being transferred to cardiomyocytes. So we have action potential curve, if you remember. Not too much we'll speak about this today. In general, we have four phases. This is resting potential. Then we have sodium channels opening, yes, and influx of sodium, then exflux of potassium and calcium influx. Then potassium starts from here, plateau phase, and so on. Then here start to work. And sodium potassium ATPases, sodium calcium exchanger, and status quo, so initial condition, is coming back. So this is depolarization, this is repolarization. This period of potential curve, it is absolute refractory period, this is relative refractory period. And as a result, look, from minus 90 millivolts, we have plus 30 overshot. Change in charge. This is depolarization. Depolarization means that plus, look, if you are looking from the external surface, it looks like this. If this will become negative, accordingly here will become positive. But we are looking usually from the external surface, there is some sources internal. Okay? So, when charge is changed from initial resting potential, it's called depolarization. Opposite process is called repolarization, when minuses are becoming pluses. This is repolarization. This is depolarization. Okay? This. Where plus has become minus. Now pay attention to action potential curves. Here are for cardiomyocytes, this is for myocytes. They are similar but not exactly the same. What is very strange, this fourth. Look, it is horizontal. It's oblique. This is called critical resting potential. It's called spontaneous diastolic depolarization. Due to this heart has automaticity. So it is not resting. It is giving potential, forming potential. So this force is oblique. Okay? In comparison to cardiomyocytes. This part was clear. Then we have, I told you P stands for atrial depolarization, QRS for ventricular depolarization, T for reticular repolarization. QRS is ventricular depolarization, but various parts. Q stands for depolarization of interventricular septum. R stands for depolarization of all other parts rather than basal parts. Basal are those which are just below the atrium. Then impulse is coming back and depolarizes basal parts, though very often we speak about left ventricle. Remember, if mass is more for any chamber, normally left ventricle is a few times thicker than the right one. So accordingly, potential which is given by it is higher. उसके साथ सोल्यूशन ऐसे उठा So, accordingly, we have Q, R, and S. Duration of Q, 0.02 seconds. Average of R is 0.04. S, 0.06. Summarizing, we are getting 0.12. This is normal duration of QRS complex. So, remember that QRS complex normally should be less than 0.12. It is called narrow QRS complex. Above this is called wide or broad QRS complex. It's already pathological. Now let's understand this QRS, how it's formed, okay? About the rules of electrophysiology we have not done yet, yes? Write down 3 rules of electrophysiology apart. For heart electrophysiological rules. 3 rules we have. Rule number 1 states that depolarization starts from subendocardial layer of myocardium and is directed towards subepicardial layers. Look, if here is endocardium, here is epicardium, this is myocardium, yes, between. So depolarization starts from here to here. This is depolarization direction. Repolarization has opposite direction. Repolarization starts from subepicardial layers of myocardium because we are speaking about myocardium. From these parts and is coming towards these parts. Okay? So 3 rules. First rule states that depolarization starts from subendocardial layer of myocardium and is directed towards subepicardial layers. Which means that at first we have depolarization of this part and this part and this part and like this. Second rule, repolarization has the opposite direction. From subepicardial layers towards subendocardial layers of myocardium, of course. Do not think that it is epicardium or endocardium. No, myocardium. And third rule states the vector of repolarization is smaller or less in size and is more slowly. Is slower. So smaller and slower. Slower like this. Slower. That's why T wave is shorter than R, but is wider in duration. Okay? So 3 rules. Subendocardial to subepicardial is depolarization. Repolarization is opposite direction. Repolarization vector is smaller,
And
for example,
slower.
like this, and slower.
Slower.
Vector of repolarization is less than vector of depolarization, and it is also slower. For understanding how this QRS is formed, we are using one method which is called like method of extrapolation. You know what does it mean? Extrapolation. Extrapolation is if for judging about subjects which are more, we are taking less sample, and knowing what happens here, we can spread this information on the whole. For example, if in your group, I don't know, from 30 people, for example, I'm telling you, okay, from 30 people, 15 are boys and 15 are girls, you may tell that 50% are males, 50 females. But for example, to take that university, 50% are males, 50 females, may be wrong, but may be right. But if we don't have any other data, we should take one group and spread on the whole university. The same we are doing here. For understanding what happens in the whole mind, experimentally, they have taken one myofibril and saw what happened there. Then these data are spread on the whole myocardium. Okay, look how it happens. We are taking one and here is placed one positive electrode. Doesn't matter what, because it's V1 or V5, that doesn't matter. It is one myofibril. And here is attached device which is measuring difference of potentials. It's called galvanometer or voltmeter to measure delta phi.
Yes.
Pressure, potential difference, gradient. So from now on, only external surface I draw. It is the same like this. Now we should use these three rules and understand what happens. Or you may write down a title like action potential in a single myofibril. Action potential in a single myofibril. Here let it be. Here is endocardium. Okay, here. For example, this part let be endocardium. Here let be epicardium.
Endocardium,
Epicardial layers, endocardial layers. So, first moment. First moment, as you can see, all have the same charge, which means that delta phi is zero. Accordingly, here we have straight line. Like this is moment 0, not 0, 1, 2, 3, 4, 4, no, just 0 moment from the start, or 1, doesn't matter. This is just symbolically we are writing, let it be 0. First moment starts depolarization. Depolarization starts. Plus, 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 plus. From subendocardium to subepicardium, yes? So depolarization direction is like this.
Yes.
It is direction of the process. Direction of process. It's not vector. Yet. And this one has become minus. This one first. This is what we had before. This was baseline. Now appears. It is not convenient. Let's take opposite. This. Afterwards I'll tell why. For us to be convenient, because from this side I've placed. Let it be here epicardium. Okay? Endocardium. Sorry, but endo, epi.
Because we have to go from
Endocardium, epicardium. A bit later I'll tell you why. So everything was positive. Now this one
Negative.
is becoming negative. The polarization process already will be like this. So here, apparently, delta phi is above zero. It's not zero. Appears difference of potentials. In other words, it's electrical current, electricity. In comparison with classical physics, in classical physics we are showing direction of electrons. Here is the direction of electrical force. It is from minus to plus, like this. And the most convenient theory to explain these changes is vector theory. About this we have spoken. So for vectors we have minus to plus. Minus to plus, minus to plus. If vector is directed towards active electrode, we have upwards deflection. If we will be opposite side from this, we will have negative deflection. So we have this. It is called conventional R wave. Why conventional? Because it is in single myofibril. If we will have in whole myocardium, it will be called R. Okay, as you understand, then it is becoming minus, then this. So it is reaching its peak, then is coming back by those lines. This is conventional R wave. R wave conventional. So next moment, second. Depolarization is over. Repolarization is not started yet. Depolarization is over. Is over means that all are negative. Delta phi is again equal to 0. Now everything is minus. Let's see what we may have. Ishka, 1 Yes, this R wave we had. Now we'll have second isoelectric line. Because no difference of potentials. Then it will correspond to ST segment, which usually is on the baseline. So it is showing the condition of myocardium when depolarization is over, repolarization has not started yet. Was clear?
Yes, sir.
Third moment. I'll try to do like this. Third moment. Starts the repolarization. Everything was minus. Here was endocardium, here epicardium should come from this side, yes? Repolarization is like this. Process has opposite direction. And this one, first under epicardium, is becoming plus. What we have? Again, vector which is from minus to plus. Always is from minus to plus. Though process had opposite direction, vector is always from minus to plus. Now let's see what we may have here. We had this, yes? And this. Should be again positive deflection. Third rule states that repolarization vector is smaller
Then depolarization.
and slower. So we'll have conventional T like this. Smaller and slower. Then when everything will become positive, we'll have what? Again isoelectrical line. So this is the same as here.
Yes.
Look, we started from here,
Yes.
T, then for example starts this.
Again flat line. Flat.
It is the start of another QRS complex, yes? Then will become. Okay, was it clear? It is very important because just now we'll do it for the whole myocardium. Remember this. Let's start from the depolarization of atria. This you may take a photo if you want. Done? Remember that the most convenient theory now to explain electrical current are vectors, because vectors besides value have direction also. So, the polarization of atrium, P formation. At first we have the polarization of right atrium, yes? Then 0.02 seconds later, left atrium. So this is right atrial component, this is left atrial component. But in total we have one P wave normally. This is P wave. P. ECG criteria. Duration should be less than 0.1 second. Amplitude should be less than 0.25 millivolts or 2.5 millimeters. It's the same. And I'll explain. For example, 0.11 already is pathological P. It is in second lead, like this. And if we'll see the time between these two peaks, it will be less than 0.02 seconds. It is maximal time during which impulse is spread from right atrium to the left atrium. Less than 0.02 seconds. And amplitude is less than 2.5 millivolts. It is in second lead. Because second lead is in the frontal plane. But if we look for the V1 recording lead, look. This is right atrium, this is left atrium. Right atrium, left atrium. Left atrium is behind the right one. It's like this, yes? Up. So in V1, the polarization of right atrium is towards the active electrode. This is right atrial component. Left atrium is opposite direction, yes, because it's behind it. So we have negative deflection. In other words, normally P wave may be biphasic in V1. Okay, plus minus. This is right atrial component or positive component. Second one is called negative component or left atrial component. And if you remember, like R2 was greater than R1, greater than R3, yes? Analogically, we have that P2 is greater than P1, greater than P3. This is electrical axis of atrium. This was for ventricles. Last week I told you. Okay? That's why the largest P we expect to get in second. That's why in determination of heart rate, pacemaker, and so always we look first of all to the second lead. Was clear? If you need, you may take photos without special limitations. Done? Okay. So this is clear. Now action potential in myocardium. QRS formation. About operations with vectors we have done?
Capital and
No. How to summarize vectors? No? If two vectors have the same direction, opposite directions, we have not done. No, yes or no? If vector A has the same direction,
we will add. Yes, we finish. Yes.
Yes,
Yes.
we are adding.
We are adding
C is A. Now we'll leave it. That's what. Yes. Action potential in myocardium already. Action potential in myocardium, which on ECG means QRS formation. Now we should use not only that three principles, that three from subendocardium to subepicardium, and so on. Also, we should remember the sequence. That at first we have the polarization of interventricular septum. Then the polarization of all other parts, apical, lateral, besides basal parts. S stands for the polarization of basal parts. So first, the polarization of interventricular septum. I've already told you that it starts from that it starts from the left parts. The left parts were receiving a bit early. So from now on, we'll draw myocardium like this, only ventricles. Schematic view, plus V1 here will place, plus V6. Now we are using two electrodes. This is right ventricle, that's why plus V1. This is left ventricle, that's why V6. Imagine that here is V2, V3, V4, V5. But we may use 10 leads, doesn't matter. Convenient is to use 2. And let's see what we have in V1 and in V6. Everything was positive, 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 yes, before. Now, starts interventricular septum depolarization from the left parts. This is the left part, towards the left ventricle. So we have minus, 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 this is plus, plus, plus.
Yes.
What we have? Vector which is from minus to plus. Accordingly, in V1, before this everything was positive, was like this, yes? Isoline.
Yes.
And in V6 also was isoline. Before starts the polarization. Now starts. So vector is directed towards V1. So in V1 we'll have positive deflection. It's small r. Why small? Because interventricular septum thickness, accordingly electric electric, is less than ventricles. And this, the same vector, has the opposite direction towards V6.
Negative. Downside.
Q for because we are its action potential in ventricular myocardium, QRS formation. Actually, we have first letter, which is wave, which is negative, it's called Q. And any letter which is positive in QRS, it is R. Was it clear? Now I will erase this, but this. Okay, remember. Now second moment. The polarization of all other parts
except
besides basal parts. It is second moment. So the polarization of all parts, of course, logically, interventricular septum already is depolarized. Besides basal parts. Pay attention, it's not the base of the heart, the basal parts of ventricles. Base of the heart has opposite direction. It's like top of atria, if we think like this. Because opposite side is apex. In other words, we need to R formation. Look, the same vector in one lead was R, in another lead was Q. That's how it is looking. Left should be a bit thicker then. Again, the same, plus V1 plus V6. And what we had in V1 before this? In V1 we had this, yes?
Q.
V1. Now we have the polarization of all parts besides these basal parts. Mainly about left ventricle. From subendocardium to subepicardium, yes? Everything was positive, 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 positive. Starts the polarization, minus, 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 endocardium to epicardium. For right ventricle, it is like this. Yes? From each subendocardium to subepicardium, here is epicardial part. External part. So we have two vectors at the same time. One vector is this,
Negative to positive.
and second vector is this.
Yes.
Left ventricular mass electrical activity is higher, so vector is larger. So if we have two vectors which have opposite directions, for their summary, we are taking and subtracting the smaller one from the larger one. And the difference will be our summary vector, which has the direction of the biggest one. Biggest is here. So from these two, I'll get this vector. It is directed towards V6.
Positive. Yes. Bigger. Small.
But it has opposite direction towards V1. They coexist at the same time.
Yes.
That's why we have one summary vector. Very interesting is going there. After 10 minutes, those who want may leave. The official time is over. Okay? If you are tired. Then this will come to its baseline. Then this will come to its baseline. Of course, the polarization is over. Gradually increases, decreases. So, is it clear? Just going forward, look, for these basal parts, mainly concerns to the left ventricle. For right ventricle, this will become minus, 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 minus. So, if everything is minus, delta phi is 0. So, we'll have isoelectrical line. It is ST segment formation. But for V6, we need to have S. I'll explain. Then ST segment formation. So, this is over. Third moment. The polarization of basal parts. Before each group exam, come to consultation. If you want. Sir, the polarization of basal parts. S formation. Remember what we had in V1. In V1 we had this before this.
P, Q, Q.
Yes, or S we had.
This is Q, this is S.
And here we had QR. And we have depolarization of basal parts. Direction of depolarization is like this. Down to up. But we consider it like it has opposite direction. It will be like this. Because then it is projected like this. So, it doesn't have any impact on right ventricle. For right ventricle, now everything is negative. It is isoelectrical line, ST segment formation. Here we have opposite directed vector. More beautiful. So the negative deflection, S wave formation. Then when everything is negative, we'll have ST segment formation. But of course after S. This is the polarization of ventricles. Now starts repolarization of ventricles. T wave formation. This is clear. Wave formation. Again, plus V1 plus V6. What we have? Everything was negative, yes, starts repolarization. Repolarization always starts from subepicardial layers to subepicardial layers. I'm writing in 2 lines, maybe millions, of course, here. But direction. So I have 2 vectors. One is minus 2 plus here, and second is minus 2 plus here. Yes?
Opposite. Okay.
So look, for V6, just going forward, and to be honest, from V2 to V6, it's the same. This is larger vector, so summary vector will be directed towards V6,
Positive.
and always we'll have positive
Yes.
T wave.
T wave.
But this is only for V6.
6.
For V1, we have a few options. For V1, normally, it is also. For V1, we have 4 variants. Variant 1, it's called domination. Domination means that V1, domination is this case, that V6 vector. V6 vector is much more than V1 vector, like this. Accordingly, this summary will be
Along to the V6.
This sum is directed to the V6, so opposite to V1. In V1, we'll have negative T wave. Normally, this is one variant. Variant B. Variant B is called independence of vectors. Independence means that V1 is for itself, V6 is for itself, and somehow their electrical fields are not interacting. Like this. Is not equal, but don't have anything common. So imagine that it is not here. If only this will be, we'll have what? For V1. Vector which is directed towards V1. We'll have positive T wave. Imagine this vector is not here. Only this one. So independent. Variant C is called neutralization. Neutralization means that force of V1 is approximately the same as V6. Neutralized. So summary vector will be 0. And we'll have like this. It's called flat T. Flat. Just a bit above baseline. No, directly. Some wave you see. But I'll not tell you it's positive or negative. And even we may have variant D when it is biphasic. Biphasic means that plus minus. One part is above, another is below, which means that for the first period, one vector is more dominant, second period of the recolorization, another vector. So, summarizing, for V1, T wave may be positive, negative, flat, and biphasic, normally. And when we are speaking that QRS, R is always positive, Q and S always negative, it is in all cases, no pathology. And that P wave may be biphasic, already you understand. So, ECG nomenclature measurement. Be attentive, we have PR interval. From the start of P wave up to start of QRS complex. PR segment from the end of P wave up to the start of QRS complex. I told you, Q may be skipping. Again, interval is called PR. Last week I told you what is PR. PR is the time during which impulse, which is produced by sinoatrial node, is depolarizing atria, is passing through the AV junction. Yes, lower parts of atria, AV node and upper part of this part. Passes through the His-Purkinje system and reaches to the cardiomyocytes, because Q already is depolarization of ventricles. In other words, it is giving us quantitatively condition of AV node, conductance. ST segment is very important, especially in ischemic heart disease. Normally, it should be more or less on the baseline, because delta T usually is equal to 0. It is starting from the J point junction. J point is the end of QRS complex and start of ST segment. About this we have spoken. About this also we have spoken. QT interval is called electrical systole here right now. So what electrical systole? It is also very important interval. Values please learn from 0.33 up to 0.44 usually, or 0.35, 0.44. Just a minute about ST segment, I'll tell you now. Look, variants of ST segment. In V1, V2 is allowed a bit up to 2 millimeters elevation normally. In other leads, this is J point, look. In other leads like standard, V6 and so on, up to 0.5 millimeters maybe above or below baseline. Normally it is more or less on the baseline. For example, in acute myocardial infarction, we raise the segment elevation. Sometimes T is fused, it says TT elevation. It is just as a value. Now, about how to measure measurements. ECG paper is millimetric paper. It has small boxes and large boxes.
Yes, 1 millimeter.
Each small box, horizontally and vertically, is 1 millimeter.
Yes.
So, height and width are 1 millimeter. Each large box in total contains 25 small boxes.
Yes.
This is clear. Now remember, for ECG we have like two sizes, vertical and horizontal. Vertically, if we are speaking about waves, it is amplitude. Amplitude is measured in millimeters or millivolts. Meanwhile, horizontal size is measured in time units, seconds or milliseconds. For example, if I want to measure amplitude of P wave, one small box, 1.5 millimeters. I don't know, S wave, 1, 2, 3, 4. 4 millimeters depth. Remember that for positive waves we are telling height, for negative waves we are telling depth. This is PQRST, sometimes you doesn't matter. Now look, I thought that we may measure in millimeters or in millivolts. But millivolt or volt is the difference of potentials, delta phi. How it became like length measurement. It is coming from calculation. If we are attentive, before each ECG starts,
Standard calibration.
I get here. Somewhere I should have.
Standard calibration. Standard.
Before each ECG starts, we have such kind of sign.
Standard calibration.
Standard calibration, it is like Greek capital letter
Yes.
T, like this. It is called millivolt.
Yes.
What is this? It is for calibration. Calibration is like the tuning for musical instruments. Calibration device wants to understand it is working properly or not. So for calibration, before starting registration from the patient, device itself gives in standard conditions 1 millivolt difference of potentials itself to the paper. Electrical current 1 millivolt to the paper. And it should give 10 millimeters deviation. Like one large box, two large boxes. Okay, 10 millimeters. This is 10 millimeters. 10 small boxes. Look, one large box, two large boxes, 10 millimeters. So, if 1 millivolt is giving us 10 millimeters, we want to understand that 1 millimeter, which is one small box amplitude, yes, is how much? X. From here, X is equal 1 multiplied by 1 over 10, 0.1 millivolt. So each small box is 0.1 millivolt. Each large box will be 0.5 millivolts because 5 both horizontally and vertically. So, for example, if we want to tell that P wave is equal to 2 millimeters, it's the same to tell that it is also equal to 0.2 millivolts. Even very often you may see plus 0.2 for positive waves,
Positive.
but we may say that for S, for example, it is equal to minus 0.3 millivolts. Millivolt cannot be negative, but it is just showing that it is negative wave. It is the same as 3 millimeters below the baseline.
Yes.
Okay? So this is what concerns to the amplitude. So vertical size. But we have also, we have also vertical size, we have also horizontal size. Horizontal size depends upon paper speed.
25. 25.
With some exact speeds, paper is passing. Imagine that somebody with a pencil in hand is sitting inside the machine and is drawing there. Depends, yes, how quickly or slowly this paper will pass. We have two variants, either 25 millimeter in a second or 50 millimeter in a second. In 1 second, 25 millimeters are passing.
Yes.
Horizontally, which means 5 large boxes or 25 small boxes. This nowadays is not widely used because it has twice higher speed, 50 millimeters in 1 second, but it is using twice more paper. So in some conditions, how to say, visualization may be better for tiny waves because it is like more prolonged, you see. Okay? Complexes, size and so on are higher. By the way, when I told 1 millivolt, 10 millimeter, it is on ECG device, there is a button, it's called sense. It is sense. Sense you may change. For example, if your QRS complex is low, you may increase the voltage, you may give 20 millimeters millivolt. But standard is 10, which means that each small box will be 1 millimeter will be 0.2 millivolts. It should be attentive. And vice versa, if your QRS complexes are very large and it is like out of the borders of the paper, you may decrease 5 millimeters millivolt. It is
0.5.
sense. Sometimes it's 12.5 millimeters in a second, but this is usually for monitors. It is not nowadays used. It is also so mainly we concentrate on 25 millimeters in a second. Now let's understand how to measure. You remember that both horizontally and vertically, one small is
0.1 or 1 millivolt.
in 1 millimeter.
Yeah.
Now look, if in 1 millimeter paper
25
passes 25
seconds.
I'm sorry, if in 1 second, in 1 second passes 25 millimeters, we want to know how much is 1 millimeter, which is one
0.4.
small box.
0.4.
From here we can conclude 1 over 25, it is 0.004 seconds. So one small box is 0.004 seconds if paper speed is 25 millimeters in a second. Here it is. Which means that one large will be 5 times 0.004, 0.20 seconds. And look, 0.5 millivolt, 1 millimeter is 0.1 millivolt. If paper speed is 25 millimeters, if, for example, will be 50, it's not difficult. If 50 millimeters, in a second, so calculation will be like this. In 1 second, we have 50 millimeters, 1 millimeter,
0.2.
0.02.
Yeah.
One small box, one large will be 0.1. 5 times 0.02, 0.10 or 0.1 seconds. Okay?
Yes.
But from this, amplitude is not changed. It is only duration, horizontal size. Vertical size is not changed.
Yes.
Still, we are measuring in the same units. Why is it important? For example, we want to measure RR interval from one QRS to another. We are measuring how many large and small boxes are between them. And we may tell, for example, that between them is 0.6 seconds. Okay? quickly, let's pass through them. Values are written either in seconds or milliseconds. For example, 120 milliseconds is the same 0.12 seconds. Both are used. So 1000 times. But it is like more obvious. Instead of telling 0.1 decimals, you may tell 120 milliseconds. The polarization I told, pacemakers I told, this is for you to read. Standard calibration, you see 0.1 millivolt in millimeter or 10 millimeters millivolt. Impulse conduction, P, then QRS formation, PQRST, PR interval, ECG rules. We have 10 rules of Professor Chamberlain. First, PR interval should be from this little less than 3 to 5 little squares or small doses. So 0.12 to 0.2 seconds. Less than this is called short PR, for example in WPW. Above this is prolongation, which is typical for example, first degree AV block. Second rule, QRS complex should be less than 0.12. 110 is already less. I would say 120 is borderline. Just 120 you may consider as narrow end. But a bit above this already is broad. Second, the QRS complex should be dominantly upright, which means that mainly R wave should be seen, especially in first and second beats. Next, QRS and T wave tend to have the same direction in the limb leads. Look, R positive T, R positive T, R positive T. In AVR we have negative QRS complex, negative T. Just going forward, let me tell you that majority of waves are negative in AVR. Though here is written that rule 5. All waves are negative. No, sometimes some small R you may reveal here or here, either before or after, so your QR or RS complexes. But like to have QS complex, you remember that we don't have any positive wave and R waves are lost, is completely normal for AVR. Remember, from V1 to V4, R wave progresses, increases the size. Look. In V4 it is becoming maximum, then gradually decreases, V5, V6. S wave grows from V1 to V3, then even may disappear. So I have opposite direction like this. Lead, where, precordial lead, where R is equal to S, like this, is called transient zone. It is usually localized in V3. If you look at V3, you can see that R is equal to S. Transient zone. Next, rule number 7. ST segment should start isoelectric except V1, V2 I told you, where it may be a bit elevated. 8. P waves should be upright in first, second, V2 to V6. If you remember in V1, maybe biphasic is normal.
And down,
Third and AVL also we are not speaking. 9. Q wave duration. By the way, Q wave normal should be less than 0.02 seconds. And its depth, it is deep wave, yes, it's negative wave, should be normally less than 1/4 of its complex R height. Look, this is, for example,
Q.
Normal Q wave. But this is pathological Q wave. Of course, if we are not speaking about AVR. Because it is approximately more than half of R wave. Understood? And also duration. If this is normal, if Q will be more than 0.02, usually 0.03 and above, is already pathological, and or Q is more than 1/4 of its complex R. What does it mean? It means that Q you should compare with its complex R. For example, we have Q here is second, and I compare with R second. I may not take Q from here, but compare with R in V3. Okay? We'll get wrong results. So, There should be no Q wave or only small Q. Less than 0.04, above this is for sure pathological. It is from source to source is different, but 0.03 already is not normal. Then 0.04 seconds in width in first, second, V2 to V6. That's why I thought Q wave is not mandatory. Is not mandatory wave. And 10, the T wave must be upright in first, second, V2 to V6. If you see T waves are positive. P wave. I thought the largest wave is second. Look, always positive in lead 1 and 2. Always negative in AVR. Duration less than 3 small squares. 3 small squares. 0.12. 0.04 times 3. I thought 0.1 is borderline. Less than is 0.13. Less than 2.5 small squares, which means 2.5 millimeters or 0.25 millivolts. Commonly biphasic in lead to E1, I told, and best seen in lead second, yes. Short PR interval, for example, if we have accessory pathway like Kent's bundle, which are rapid pathways, which are fast pathways, and they are connecting atria with ventricles. And it passes sooner, right, from atria to ventricles. That's why PR is becoming short. Long PR, for example, in first degree, look, if we measure one large box, look, approximately 2 large boxes. 2 large boxes is 0.2 times 2, 0.4. 0.2 was borderline. 0.22 already is pathological. Here, okay, they have measured more accurately, 280 or 0.28. 0.22 already is abnormal. QRS complex is non-pathological Q waves may be seen. R wave in lead sequence. I told you R wave grows, then decreases. This is important. Pathological Q wave more than 2 millimeters deep and more than 1 millimeter wide. 1 millimeter is 0.04 seconds. 0.04 is given because one small square is 0.04. Less than this, maybe not too much visible. Or more than 25 or 1/4 leads complex of the subsequent R wave. ST segment flat, we start from J point, variance of ST segment, variance of elevation with myocardial infarction. That should be at least 1/8, but less than 2/3 of the magnitude of R wave. Remember, the T wave is asymmetrical. Upcoming slope and down sloping are not the same size. Look, first half having the gradual slope, then the second. This is gradual and this. If it is too much symmetrical, maybe seen in coronary artery disease. That's why we distinguish not from pathology. These are T waves, QT interval. It is symmetrical. Systole, it is very important because if QT is prolonged, we may have life-threatening arrhythmias. When QT may be prolonged, we have congenital long QT syndrome. And these people should undergo ICD implantation because they may have life-threatening arrhythmias in this background. And it may be acquired, for example, in medications like amiodarone, antiarrhythmic medication. There is an anti-malarial drug which is called hydroxychloroquine, which was used also for the treatment of COVID-19. It was also prolonging QT interval. So people who are receiving this medication should undergo more close follow-ups of this ECG monitoring. But look, QT is not the same for all heart rates. Heart rate increases, QT decreases, and vice versa. It's adversely proportional. Inversely. Now look, we have QT QTC for this, QT corrected. QT corrected is QT, there are a lot of formulas, this is Basel's formula. QT calculated, which you calculate on your patient's ECG, then you divide over square root of RR interval. There are a lot of formulas I'll show you. Very often we are taking lead AVL where the likelihood of U wave is less, so because this will make confuse it is T or U started. From the start of QRS complex up to the end of T wave. Look, there are a lot of formulas. Hodges, Framingham, Frederica. Usually we are using Basel's formula. Each of them have limitations. How to do this? We have a lot of online calculators. I'll show you. Look. Corrected. And we got, for example, this one. It is asking you which one you want to use. For example, Basels. We are measuring heart rate because by hour we measure heart rate. Beats per minute, it is not changing. For example, let it be 70 beats per minute.
Okay.
Paper speed 25. It is giving you one large box, one small box. Heart rate. And 70 beats per minute. Let's make steps.
No, you have to put that.
Correct. Basels formula.
No, you have to put page QT interval.
No.
QT interval. you have to
QT
put.
interval. Either we may give in small boxes, or we may give in seconds or milliseconds. Here's milliseconds. For example, let it be 0.4 or 400 milliseconds. Look, QT corrected is 432. QTC normally is QTC. It is corrected. Okay. Should be less than 0.45 seconds or less than 450 milliseconds. Otherwise, the likelihood of life threatening conditions increases. Now, if instead of 400, I place here 480, it is already becoming pathological. No, your calculated is normal. 420 is 0.42 is normal.
No.
Absolutely. But for this heart rate, it's not enough. Now, if instead of 70 beats per minute, I'll give 60. QTC, QT calculated will be the same. Why? I told that QT is inversely proportional to heart rate. Heart rate increases, QT decreases, and vice versa. So, all these formulas, especially Basels formula, is calculating how much will be patient's QT if heart rate would be 60 beats per minute. That's why in case of 60 beats per minute, like this is becoming 1, and corrected is becoming equal to, because now we have not passed it, but let me tell you, if heart rate is equal to 60 beats per minute, it means that RR interval is 1 second. Accordingly, QT corrected will be QT calculated over square root of 1, which is 1. So we'll have QT
equals
C. Okay? So it is measuring how much should be QT in case of if patient's heart rate would be 60. If patient's heart rate is too much tachycardic or too much bradycardic, these formulas have some limitations. What I told you is still working. If you don't want, you may go. Those who I'm telling this. Anyway, one extra lecture is coming. Maybe even on Friday. On Friday you are free?
Yes.
Tomorrow you are free?
No, tomorrow we have check.
Huh?
Till 12:40.
No, after.
Yes. After 12:49.
No, we are not free.
Okay.
On Friday only, sir. Friday तो सब टोपो है ना?
I'll tell you on Friday or on Saturday, or maybe online, but online is problematic.
On Friday.
Because somebody is entering, somebody is signing out, you are admitting, they are losing, I don't know. You don't know they are here or not here. And 10 minutes break after each 40 minutes.
Saturday.
Then again the same starts. 10 minutes you are admitting, 10 minutes
टोपो we don't have full day.
we are waiting.
पूरा Saturday लेना है तो Friday.
What is this?
Yes. Friday.
U wave is not mandatory wave. After T wave, very well is seen in V1 to V3. more prominent at bradycardic rates, so it's low heart rates. It is called to after depolarization, so it is repolarization part after depolarization of papillary muscles. May be seen in hypokalemia, for example. What is coming? Determination of pacemaker. Today you are tired, I will not tell. But with calculation of heart rate, now we'll do. And by this we'll finish. Determination of heart rate, one of your exam questions. How to determine heart rate based on ECG. Otherwise you may check the pulse, but on ECG how to determine heart rate. For determination of heart rate are used few methods. Universal formula, heart rate is equal 60 divided over RR. Special tables mean that there is RR is measured, and for this RR you know how much is heart rate. ECG rulers, next time I'll bring and show you. It's a special ruler. You are selecting 2 or 3 QRS complexes, one arrow, and second arrow already is written 100 beats per minute, 120. It is calibrated ruler. And ruler usually has 2 sides, one for 25 millimeters, second is for 50. And the rule of large boxes or the rule of 300. Now let's understand that this is very problematic. Somebody may work hard. Like me. Then at home I'll suggest you to complete this lecture, or if only this part is remaining, determination of pacemaker. Next time, tomorrow I have lecture with your other groups. I cannot promise you that, but I think that large room will find, because classes are more or less over now. I mean, exams, midterms, like this. So, look, how to determine heart rate. PQRST. 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 If rhythm is regular, RR interval is regular. This is RR, from one QRS complex to another. If, for example, will be sinus rhythm, you may measure PP interval, because from one P to another P is the same as from one R to another R, from one S to another S. But usually R is a prominent wave. That's why RR interval. But it's not dogmatic like. You may do SS, because 1 to 1 is proportional. So, if a heart rhythm is regular, it means that RR more or less is the same. So this formula is showing that 60 heart rate is equal to 60 divided over RR interval. RR interval is some X value. 60 is the number of seconds in 1 minute. Look, 60 seconds. If we divide over RR interval in seconds, by the way, it's called RR interval, not respiratory rate, as students usually are telling. Not R minus R, it's not minus. R to R. So we'll get some X beats per minute. So by dividing 60 number of seconds in 1 minute on some average value of RR interval, it will show us that from one QRS complex to another QRS complex, how much is the distance. In other words, we may know how much QRS complexes we had in 1 minute. One heart cycle is PQRST. So by knowing how much PQRSTs we have, or QRS if P is absent, for example in non-sinus rhythms, we can tell how much is the patient's heart rate. For example, let's imagine that between them we have 1, 2, 3 large boxes and 1, 2, 3, 4 small boxes. RR, this is how we calculate, is equal to 3 large plus 4 small boxes, which means 3 times, if 25, 3 times 0, 2, yes, plus 4 times 0, 0, 4. It means that it is 0, 6 plus 0, 1, 2, it is 0, 72. So heart rate here will be 60 divided over 72. I think you will get something like 75 beats per minute. Okay? You may calculate, doesn't matter. Way how you are calculating matters, not how you divide. Was clear? Special tables already you understand. There is a table is written RR and heart rate. For example, RR is equal to 1 second, heart rate is 60 beats per minute, 60 divided over 1. RR is 0.5, heart rate is 120. RR is, I don't know, 2, heart rate is 30 beats per minute, for example. ECG rulers. ECG rulers are used like this. It's usually written 2RR or 3RR. Depends which time. Let's take 2RR. It means that we need to have 2RR intervals. In other words, 3 complexes. 1 RR interval, second RR interval. So 1 arrow is placed here, it is 0. And in front of second arrow, which value you see, for example, 80. This will be heart rate. It is also used. To be honest, none of them is used.
Last one.
Largely.
Last one more.
Very often we do it visually. The last one, okay, yes, it is practical.
Yes.
It is called the rule of 300. If paper speed is 25 millimeter in a second, if heart rate will be equal to 300 divided over the number of large boxes between them, if exactly over the large boxes. Imagine that here I have 1, 2, 3, 4 large boxes, just exactly where on this. 300 over 4, I'll get 75 beats per minute. That's why I told something like 75 we may get. Because it's very close. Look, 4 small is approximately the same as 5 smalls. 5 small is 1 large. 3 larges I get. 1 large more, 4. 300 over 4, 75 beats per minute. Action, operation which are doing daily. Number of, and you may see that number of big boxes 1, 300, 2, 150. If paper speed is 25, 600 is divided over the number of large boxes. What is the heart rate? Look, 1 large box, 2, 3, 4, 5. Imaginary, I may replace this one to be exactly here, this one will come here. Yes, symmetrically if I will. So, 6, 300 over 6, 50 beats per minute. It is atrial flutter, to be honest, we don't have. Look, PQRST we don't have, I mean, we have, P we don't have. These are F waves with T fused. So, RR, but I see 1 large, 2 large, 3 large, 4 large, approximately 4, 75 beats per minute, approximately. So this is VT, ventricular tachycardia. So, I may measure SS or RR, okay, 1 large. 1.5 larges, 200 beats per minute. Okay? So, what is left for us is our hypertrophies. I will explain this now. Pacemaker determination. But, please complete this at home to be clear. And one last thing. How we got this 300? For long years, I was telling students that it's some empiric value. 300 we are dividing, but 300 is not coming out of nowhere. It has a meaning. Now look. It is called the rule of 300 or the rule of or the law of large boxes. Once more, we start from if. If velocity is equal to 25 millimeters in second, yes? One large box is equal to 0.20 seconds. Yes, you remember. One large box.
Yeah.
Now we want to measure heart rate. Heart rate is beats per minute in 60 seconds. Now, if we'll divide 60 seconds, 1 minute, on duration of one large box is 0.2. I'll get 300 large boxes. So in 1 minute, if we'll not stop ECG, ECG paper will bring out 300 large boxes. Now if it's connected with the patient, with traces. It's not connected, just blank.
Mhm.
300. So it's maximal number of large boxes in 1 minute. Cannot be more. Accordingly, if it is 50 millimeters in a second, yes, one large is 0.1 second. 60 over 0.1, 600. That's why 600. So if in 1 minute we have 300 large boxes and RR interval is more or less fixed, even you may use half, or 3.5, 4.5. By dividing 300 over the number of large boxes between RR, we'll know how many RR intervals we had, which is the same as to know how many Poirot complexes. This 300 is coming from there. Okay?
Yes.
For not learning by heart, just. That's all.